A probability distribution given as a table such as this. We have an outcome called X. And the outcomes are 2, 3, 4, 5, and 6. There's nothing else that's possible in this study, in this experiment. We have the probability of each of these outcomes happening. 0.1, 0.19, 0.29 for outcomes of 2, 3, and 4. 0.05 for an outcome of 6. We have one missing probability. But since all of these probabilities have to sum up to be 1. What that means is, if we take 1 minus each of these probabilities, that means we can calculate the total probability. We can calculate the probability that X is equal to 5, which is 0.37. And that answers part A. Now find the probability that X is at least 4. Sorry about that. So we want to find the probability that X is at least 4. Now since this is all written out for us, then that's pretty nice. Because we can find the probability X is at least 4, which means we want to find the probability X is equal to 4, plus the probability X is equal to 5, plus the probability X is equal to 6. And again, we stop at 6 because that is the highest outcome value. If X was possible to be 7, 8, or 9, then there would have to be probabilities associated with 7, 8, or 9. So that's going to be X equals 4, which has a probability 0.29. 0.37, X equals 5, that's what we calculated. And then 0.05 for X equals 6, add that up to get 0.71. We can go into our calculator and we can input our probability distribution table in order to calculate the mean and the standard deviation. Let's take a look. And this one I'll show you inputting into the calculator. So let's hit Stat, let's hit Edit.
Off the asphalt, outside city limits, beyond.
Add. Let's clear off this list. Let's input our data of 2, 3, 4, 5, and 6. Let's go to L2 and we'll input our probabilities. Now, if you're using a regular calculator, TI 83, 84, then put it in with the decimals. For some reason, this emulator can't use the decimals, so I'm going to have to put it in as whole numbers. This will not change the mean, thankfully. It will also not change the standard deviation, thankfully. It will change some of the other totals, but we're not concerned about that because that's not the numbers we're interested in. So again, I'm putting in 10 instead of 0.1, 19 instead of 0.19, 29 instead of 0.29, 0.37 is going to be 37, 0.05 is going to be 5 for this calculator. We're going to hit second. No, we're not going to hit second. We're going to hit Stat again and go to Calc. And we're still calculating our one variable stats. But again, just from before, L1 is the default for the list up here. But we do have to put in our frequency list, and that's usually left blank. So let's hit second and 2 to populate L2 into there, telling our calculator to look at both of these lists. And then we'll hit enter. And what the calculator is going to do is calculate what's called, a weighted average, essentially. 4.08 is your average. And your standard deviation is your population standard deviation, which means we're going to use the sigma symbol, not the S symbol. So sigma X is 1.074, and that is our population standard deviation.